Hello and welcome to Unprofessional Engineering. My name is James.
You got Luke.
Luke, we're taking a look at how batteries are made today.
And here's the thing. This has been on our list for a while.
I know.
And I have poo-pooed it like every time you brought it up. And all of a sudden, when you brought it up the other day, I was like, why haven't we done batteries, James?
I know, that's such a good idea. It's like, well, it's been there since almost day one,
I
right?
literally don't know why we haven't done batteries.
I feel like someone might have just written in with this one again, too.
That might be a refresher for me. Who knows?
So, if you want some more of a quick rundown or maybe some of the other details we gloss over on this, check out vartaconsumer.com as well as madehow.com for a much more detailed breakdown of like the machinery and the things going on here.
Okay.
Granted, I don't actually know what you've covered, so maybe I'm not giving you enough credit.
Perhaps not.
Okay, so I thought maybe we could start with the parts of a battery. And I'm talking real basic, right?
Real basic.
So everyone should know that there are three main parts to a battery. An anode, which is apparently negative, a cathode, which is apparently positive, and the electrolyte. So the cathode and the anode, so the positive and the negative sides of the battery, you know, the plus and minus sign on a battery.
And then they put Brondo in the middle.
And
Because
Brondo
it's
goes
what the
in
body
there.
craves.
It is what the body craves. Is it idiocracy?
Yeah.
Is that right? Yeah.
There you
Right. So they're hooked up, the positive and negative, to an electrical circuit, and the chemical reaction in the battery causes the buildup of electrons to the anode. And so I'll get into how the battery actually works and power stuff later on. But remember, those are the three parts that we're going to discuss
Three parts.
on how batteries are actually made. So do you want to talk about history a little bit?
Yeah, we could do history.
All right. Do you have history or do you want me to talk about it?
Why don't I start with history?
Please do.
Because you always have more information than me and make me feel bad about
Okay.
myself.
I'm sorry.
So who invented the battery? So first of all,
Which one?
yeah. So the person who's credited most with this is a cat by the name of Alessandro Volta.
Italian cat.
Yeah, very Italian. He created in Volta, you get the name.
Yes.
Created the first modern day battery in 1800. But interestingly enough, batteries have gone back for hundreds of years. Not the same way we think of batteries. But he created what was known as a Voltic Pile. And it's exactly what you think of when you think of the word Voltic Pile. So he would take a pile of copper and zinc plates and alternate them. And these copper and zinc plates would typically have some kind of leather or material in between each layer, and it was soaked in some kind of vinegar or acid. And what would happen is, just like you were talking, a charge would build up between those plates, and it would produce electricity.
Wow.
Piles and piles of copper and zinc plates. And interestingly, modern-day batteries aren't all that different. They're much more sophisticated. They're enclosed inside of cases and whatnot, and they're way more efficient. But the basic makeup of how batteries are made, stacking things up, alternate, and having different materials is essentially the same.
Good job.
Essentially.
Alessandro would be happy with your breakdown of
Yeah.
that.
No, you said his name wrong.
Oh, how do you say it?
Alessandro.
Oh. Do you have to roll the R's?
You do.
Oh. Does Italian do that, or is that just Spanish?
I think that's Spanish.
Okay. How about we move on to 1813?
I'm cool with 1813.
Sir Humphrey Davy constructed a pile, so a voltaic pile, I love that, of 2,000 pairs of discs in the basement of the Royal Institution of London.
And blew the place up.
It is now gone. Now, I don't know about that. Among other applications, he used the electricity produced for electrolysis, catalyzing chemical reactions by passing a current through the substance.
Electrolysis? Is that where you get rid of the hair on your upper lip?
I do that, yeah. That's why I can't grow a beard or a mustache. A few years later, Michael Faraday discovered the principle of electromagnetic induction, using a magnet to induce electricity in a coiled wire. So this technique is at the heart of the dynamos used to produce electricity in power plants today. So good job, Michael Faraday.
Nice work.
Fun fact about that.
Shoot.
They produce alternating current.
AC.
AC, that's right.
Versus.
In which the flow of electricity shifts directionally. Batteries produce a direct current.
DC.
That's right. That flows in one direction only.
Mm-hmm.
Pretty neat.
And then if you want to listen to our episodes, we have episodes about Edison and who's the other cat? Tesla, and
your
all
favorite, and you don't even remember?
all the fight between AC and DC there.
That's
so.
right. A lead-acid battery, or a lead-acid cell capable of producing a very large amount of current, the forerunner to today's like automobile batteries
Okay.
that we use, was created in 1859 by some French guy, Gaston Planté.
Very good.
You like that? Do you have more? I have 1960s, but that's the last of my history.
So it was the first rechargeable battery.
Oh, wow.
Yeah,
That's
and
neat.
what they would do is they would pass a reverse current
I
through
guess that
it.
makes sense.
Yeah.
Okay.
So up until then, all batteries would be drained or spent once their chemical reaction was done, chemically reacting, and there was like nothing they can do. And basically, Gaston figured out how to, basically recharge these batteries, which I thought was pretty interesting.
During the 1860s, this isn't really interesting until the end, so stick with me.
Okay, I'll see what I can
George somebody, Leclanche, invented the wet cell, which was really heavy because its liquid components were, super heavy.
Mm-hmm.
It could be sold and used commercially only. By the 70s and 80s of the 18s, this dude's cell was produced using dry materials, so that made it a lot lighter, which was nice, and it was used for a number of tasks, and this is the interesting part.
Shoot.
One included providing power for Alexander Graham Bell's telephone.
What?
Yeah, check out our episode all about great inventor Alexander Graham Bell.
That's pretty cool.
Yeah, I thought that was rather interesting. Okay, what else do you have for history?
So back in 1899, Swedish scientist
Swedish again.
Swedish. You know what? They did pretty good work over there.
They have.
Swedish scientist Valdemar
Voldemort.
Jagander.
Voldemort.
He invented the nickel cadmium battery, and it was the first battery to use an alkali electrode.
Oh,
hence
really?
alkali batteries. And these were
1899.
way more robust than lead acid batteries. But unfortunately, because of the materials and accessibility and yada, 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 they were crazy expensive and just not very feasible. So, like nowadays, alkali batteries is like every little Duracell or whatever you get is typically an alkali. It might be a lithium ion, but an alkali battery.
I only get knockoff brands so that they die in like an hour.
You get the IKEA thing for like $9, and they're the worst.
Yeah.
Fun fact.
Tell me.
Good old Benjamin Franklin, who we haven't done a show on.
We absolutely have.
We have? Okay. I'm sorry. I forgot.
They are running together.
He was the first person to actually use the term battery all the way back in 1749.
Wow.
No one used the term battery before. And I'm sure he's lying because Ben Franklin was a shady person.
He really was.
No offense to his ancestors,
Yeah.
but he was pretty shady.
Yeah. Wow. That's very interesting. What a great fun fact.
Yeah.
Anything else with history?
So the next big jump in history, and I guess we're going to talk about modern day stuff here. So the biggest jump probably happened in 1980, actually. So we're moving like way, way, way forward. And the biggest jump was with lithium ion batteries. And the reason why this was important was to get really high output, long lasting batteries, they needed to be big. And the materials inside of them were heavy. So what they did was they used lithium ion, and lithium, in case you didn't know this, is actually one of the lightest elements on the periodic table.
I was not aware of that.
I knew
but
you
now
were.
I am.
Now you are.
You were just good at the chemistries.
Not only was making the batteries lighter, but the properties and everything else that went into lithium allowed for higher voltages and quicker recharge times.
Wow.
Huh?
Well, that is really something.
Look at me.
You sound so smart today.
I try.
All right. Before you sound any smarter than I, how about we take a break for a word from our sponsor?
Duracell, Tesla, that new truck company that's electric. I can't remember the name of
It's
it.
electric.
Boogie woogie woogie woo.
None of those.
None of those?
But we do have some shout-outs.
Thank goodness.
Shout out number 1, Kevin B., a fellow mechanical engineer, wrote in wondering, why do people always talk about the PE, but nobody actually has one except for civils, And he's like, it's kind of funny because I had the same experience in college. It's like, go get your PE, take your fundamentals of engineering, get your PE 4 years later, blah, 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 blah. Then I've actually had companies that are like, oh yeah, don't do that. Don't waste your time doing that.
Yeah.
Unless you're signing off on something. So I thought that was a good point. Stupid civils. Second shout out, Jerry R.
Good old Jerry.
Jerry agrees with our top 10 inventions list.
Nice.
For the most part, though he would put sanitation higher because he would not want to live without toilet paper.
Okay.
Wasn't exactly what I had in mind for sanitation, but I appreciate it.
Hey.
I agree.
Yeah, I'm down with that. Thanks for writing in, guys. I appreciate that.
Yeah, you know where they wrote into?
My guess is at some unprofessionalengineering@gmail.com
That
address.
is exactly right. You nailed it.
Mm-hmm.
What else could people do to help
They
us
could
out?
review, they could share, they could like, they could listen, and if they do all of those things and they let us know, guess what? We'll send you stickers.
Send you some amazing stickers.
Yeah, and the reviews are the big thing. We need reviews.
We
We're
need
looking at
reviews.
100. I'm going to say if there's a way we can figure out who's our 100th reviewer, I doubt we can.
I mean, I'd have to look at it regularly, which I do not.
If we could
it might be there now.
If we could figure it out, who's our 100th reviewer,
I'd buy them a
we're
hot
gonna have
dog.
a special gift for them somehow or another.
Wow.
And by us, I mean you have to take care of it.
Thanks, man. Thanks for putting that on me.
Sorry.
But I will do that if we can figure out
Yeah.
who it was.
So review,
if
email
you,
us, send
if
it
you
in.
show that there are 99 reviews and yours is number 100, don't Photoshop that. We will hook you up with, I don't know, maybe sending Luke to your house. That's
Perhaps.
a real gift right there. All right, can we get into how batteries are actually made, since I claimed we were going to do that?
Can we talk about how they work, or are we still saving that one?
Let's save that one
Okay.
for after how they're made.
Okay, we can do how they're made.
Do you want to talk about how they're made, or
So
do you want me to?
I say we just play it back and forth. One thing
All
I
right.
never knew was batteries actually start with a nail.
Yeah.
Like
Yeah.
a nail, like you think of a nail, like a hammer. Now, granted, it's made out of specific materials, but like the nail that you nail into a wall, like to hold up,
Sorta, right?
yeah,
Yeah.
it looks identical.
It does, yeah. So that's not how I started mine, but you're right. That is,
Mm-hmm.
I mean, there's like two pieces that get smashed together, and that nail is like the starting part.
Yeah.
And so a little bit about said nail, which is kind of weird. Let me see if I can actually find it. Well, I can't find it. So go ahead with the next thing that you. were
Okay,
going to talk
so
about.
so they take this nail, and again, it's made out of two different materials, and they kind of put these together, and it's specialized. It needs to be super clean, yada yada yada. Then what they do is they take molten zinc, and it comes in these big, huge ingots. It gets delivered to the company, and unfortunately, it needs to be turned into something that's more, feasible. So they take the zinc and they actually turn it into a gel that becomes the anode that actually wraps around the nail itself.
Yeah, that's interesting. I saw that. I
that's
saw
the
how you
wraparound.
wrapped it. That was good. Did you talk about the steel case that
I
it
did.
starts with?
I didn't. Well, yeah, I'm kind of doing this from the inside out.
I see this.
Sorry.
Okay.
Then on the outside of the anode, they have a paper separator because the
Which
anode,
I think is strange.
Yeah, the anode, but the reason being they can't touch. The
Right.
anode cathode have to have some kind of physical barrier between the two of them. And on the outside of that is where manganese, not magnesium. I typed that a bunch of times. It's manganese dioxide as the cathode is on the outside of that, and that's typically pressed into. It looks like almost like clay, like a black clay. And they're like little cylinders, and they go on the outside. And all of this is wrapped inside of a steel case. So when you think about the process,
4 of them.
yeah, when you think about the process, it starts out with the steel case. This all gets assembled. They drop in the manganese dioxide. They put in the sleeve. Then they squeeze in the anode gel. It's the noise. that
Yeah,
it makes.
that's the noise. You're right.
Yeah, that's. I'm
Zinc
sure
powder,
you might have more.
potassium
You might have more
hydroxide.
details, and they all have special formulas, which I didn't know too. Like Duracell, Energizer, they all have little things that they do differently to make their batteries better.
Yeah, I mean, you pretty much nailed it, Luke. See what I did because it uses a nail. But you're right. Steel thing, put the things in it, fill it up with juice, stick the nail in the other end, and then they seal it up. So to close the battery, the upper edge of the steel can or cylinder or whatever we want to call it is just bent over a stopper. The batteries are then ready to be packaged up. So apparently boxes hold up to 850 batteries, which is basically how I think Tesla makes their batteries, right?
Yeah.
They just take one of these big boxes off the shelf and stick it in the car. And then each battery goes down a conveyor, gets wrapped and put into its, quote, blister packs. I think because you get blisters trying to open them,
Yep.
I assume.
Did you ever see the Larry David
Then they're ready to
episode
buy.
where he's trying to open the blister pack with scissors and he's stabbing it with a knife?
No.
It's pretty funny. You should check
I
it
like
out.
that.
So I saw this one video, Duracell, over in Europe, one of their biggest production facilities over there, and I might be saying the number wrong,
Probably.
but they make over 100 million batteries in a day. It said.
So, yeah, that's a lot of batteries.
Which was bananas.
That is bananas. But how about this? More than 20 billion power cells are sold throughout the world each year. So maybe that's not so wrong, right?
That's crazy.
Also, fun fact number 2, each American uses approximately 27 batteries annually. I feel like I use that many.
We don't use any.
You don't use batteries?
Yeah, we have a lot of rechargeable things in the house.
I use a lot of rechargeables for my cat's meow.
Like the
Maybe
stuff...
they should sponsor us.
What's the cat's meow?
It's basically a plastic tail under like a drape thing that spins in a circle and like moves around, and the cat plays with it.
I can't be friends with you anymore.
Well,
So another fun fact, well, really not so fun fact, it's estimated that over 3 billion batteries are thrown away every year.
wow. That's
Can
a lot.
you imagine throwing 3 billion batteries
I throw
away?
a lot of them away, so
And I'm sure you recycle them properly.
yeah. I recycle my car oil properly too.
Yeah.
Yeah. Fun fact for you. Last one.
Shoot.
I'm probably stealing it from you. The Tesla Model S has an 85 kilowatt battery pack that weighs 1,200 pounds, which is a lot, and contains 7,104 lithium ion battery cells in 16 modules wired in series.
So here's the thing that I don't get. So I think you and I mentioned this to you when we brought this thing up the other day. So basically, they're a little bit bigger than a standard AA, I think. So it's not like a Duracell AA. It's a little bit bigger, a little bit
They
fatter.
just like paint over a Duracell.
And they write Tesla. I think I saw somewhere where they're using Panasonic batteries for certain models.
Oh,
But
okay.
regardless,
Yeah.
so there isn't a better way than to take 7,000 batteries, hook them up in series to get the power you want? I mean, that's the most efficient way. I mean, if you think of all the material and the fabrication process and like all the effort that goes in to make 7,000 batteries, you can't make like 6 really big batteries and just put 6 of them in unison. I mean, maybe it's an efficiency thing, or I'm sure there's some kind of engineering behind why it has to be. Like, why not D batteries? And then instead of being 7,000, it's 4,000.
I don't know. I assume there must
why?
be some sort of cost analysis that goes into it. I'm sure they've looked into this.
Yeah,
maybe it's like a failure thing. Like if a few of these start failing, maybe that's not so bad, and maybe they're easier to
Yeah.
replace versus one big cell.
Like,
I don't know.
I never knew that. I just assumed Tesla batteries, it was like one big battery.
I always assumed that as well.
And then you see pictures of it, and it's literally...
Is this the same with other electric vehicles, I assume?
Pretty much anything that is like this. Like the power wall is just a whole bunch of batteries in series. Like everything is just a bunch of AA's battery in series.
That's disappointing.
Yeah, there's got to be a reason behind it. I'm not sure.
All right. Well, before we get into how the things actually work and anything else, could we take a break for this week's Luke's rant?
Yeah,
Even
so-
though I felt like that kind of led us into it.
Yeah, it is. And that's not my rant. But so here's my rant. So why... And it's not really a rant. It's more of like maybe our listeners know. How come sometimes whenever I go to use my remote, it doesn't work? And then I feel like I feel like an old man saying this. I go to use my remote on my television or whatever it is, and it doesn't work. And then I open up the back of the batteries and I roll the battery back and forth. I don't pull it out. I don't put it back in. I'm not changing the fact that it's contact. I just move the battery a little bit. Or you do this, right? You take the remote and you smash it off your other hand 3 or 4 times, and then it works. Why?
I really can't give you an answer to that. I don't do that very often.
I just did it.
I've never done the roll the batteries thing.
I always open it up and I just roll the battery back and forth, and then all of a sudden the remote's like brand spanking new.
Yeah, it does seem like I don't know. Maybe there's a disconnect there somehow.
Yeah,
But
and then
I do the smash.
the smash.
I do the smash. I do that with my Xbox controller a lot too, and it usually just means that they're dead.
Okay.
I use rechargeables for that, so
okay.
I'm a good person.
I don't play Xbox.
Well, that's because you're not a child like me.
Yes.
A man-child.
Yes, it's more of like, does someone know why? Like one day a remote works, and then the next day it doesn't work, and I gotta smash it or roll the batteries back and forth.
Luke's provided you with so many answers. Why don't you give him one?
Don't know what it is.
Write into unprofessionalengineering@gmail.com and let him know.
Yes.
You know what I don't know how to use is the DVR. I always hand the remote to the wife and be like, here, make sure this show gets recorded.
I have an antenna, and that's
Oh,
all
yeah.
I have.
Well, you do live in a cave as well, so sometimes you roll a boulder over the entrance for protection.
Fun fact.
Let's
Now
hear
that we're
it.
done with my rant, the largest battery in the world is a lithium ion battery in South Australia, and it's approximately the size of a football field. Tesla built this thing. It's called the Hornsdale Energy Reserve, and it has over 100 megawatts of power, capable of powering over 30,000 homes.
How does it get its power?
Solar and wind, I believe.
Huh.
Not Nikola Tesla. I was going to say Elon Musk. This guy's a genius. He should be on the show.
We actually have an episode all about Elon Musk, right? And we actually have one about the Boring Company, like his unknown baby company.
He had this. I listened to this whole conversation he had about Australia could be 100% solar power in like 36 months or something like that. You give Elon the money, you give him some space, and 100% of their power could come from solar. And it's like, why isn't he doing more of that stuff?
What's his newest thing with all the satellites that are going to control our internets here? So like
I didn't see
it's
that.
like 12,000 satellites circling the world or something. Yeah, I mean, a lot of people hate him, but I'm impressed. I don't know. He's a terrible presenter, though.
Oh, yeah, he is.
He's just the worst at that.
That's
But I
not
guess
how
you
we get
can't
him
be
on the
good at
show by
everything.
saying that.
Elon, we can really use you on the show because your presentation skills are stellar.
Magnifique.
Yeah, he is a longtime listener. Okay, so how do batteries work? So what's happening between the battery and whatever it's powering, Luke?
Yeah.
You want to talk about it, or do you want me to?
So I'm going to give like my everyday person explanation, and I'm gonna call out a longtime listener, friend of the show, Steve K, who explained, and I've used this analogy before. You think of electricity like water, right?
I don't.
So here's what's happening in a battery. You talked about the anode.
Hold on. Don't we usually keep electricity and water away from each other?
You usually do, but if you think about the way electricity flows and the way electricity works, it's very much like water. Okay. So what's happening in a battery essentially is you have a negative side, you have a positive side, there's a chemical reaction, but that chemical reaction doesn't happen if that battery's in a steady state. So you're not doing anything with that battery. You're just sitting there holding that battery and nothing's happening. There's no chemical reaction. And I'm actually holding a Rey.
I was going to say, I think that's Rey.
It's Rey from Star Wars. But the minute you put this into a circuit, the chemical reaction starts, positive charge builds up, and it has to leave because that's what positive charges want to do. Positive charge leaves, goes into the system, and then comes back in the negative side. So if you think of just having a battery, a wire to a light bulb, and then a light bulb back to the battery. And if you think about the way water flows, it's going to take the path of least resistance. So it's almost like high pressure and low pressure. So the high pressure is where the positive charge is happening. It leaves that positive side. It goes through the system and comes back in the lower pressure side. So it's basically, it's the flow of water. And you're making a face now like you don't believe me.
I'm thinking about the positive versus negative. So here's my breakdown of it.
Shoot.
You want that? So the chemical reaction that you're talking about is in the anode, which releases electrons, which flow as an electric current over the negative pole in the load circuit. So the electrons return over the positive pole and are used in a second chemical reaction inside the cathode by that manganese dioxide, or manganese oxide?
Manganese oxide.
And power consequently begins to flow, like you're saying, like water, just not together because then you get electrocuted. Begins to flow on its way from the anode to the cathode, which ultimately causes the whatever it is you're doing or trying to power to be powered. And so the more electrons that are available, the faster they move, and therefore the greater the flow of the current.
I did have the anode cathode backwards.
Okay.
But essentially,
I'm not smart enough to know if you did or not, so that's why I was just giving that look.
I was just double checking. Yeah. So the buildup is on the anode, which is the negative side.
Okay.
Yeah. But essentially, it just has to leave the system, and that's why it creates that circuit, and that's why it's called a circuit because it comes back.
Completely unrelated to this.
Completely. Let's hear it.
I'm wondering, the battery in Australia that's giant.
Yes.
Does it have like a size, like a AA, AAA, C, D?
It's probably like a whole bunch of A's.
Man, we should figure that out.
Yeah.
Okay, so what else do you have? Because all I have left are a few types of batteries.
So I got a couple additional fun facts about batteries. We talked about how they're made. So there's some bad stuff about batteries, unfortunately.
There are?
There's bad stuff about everything.
I don't agree.
So
Have you met our podcast? Nothing bad about it.
nothing exactly. The one thing in the world, our podcast.
That's right.
So batteries, when they're not properly recycled,
Ooh.
and you and I just had this brief conversation a few minutes ago about do you actually recycle batteries? And the way you recycle them is you take them and you throw them in your regular garbage really hard so they go underneath stuff so that the garbage men don't see it and you feel guilty about it. So
Do you?
they estimate 90% of all batteries are recycled, but that's 90% of the ones I think that they know about.
Are recycled?
Are, which I think they're lying.
No. That's a total lie.
Yeah, so I feel like that number's really high. I think the vast majority of all these AA and D batteries and all that sort of stuff, I think lead acid batteries are much higher because they're regulated differently and they're typically bigger.
Do you think rechargeable batteries are counted as recycled properly when you recharge them? Because maybe that number starts to change.
Well, the lead acid is much
and
higher.
I guess there's phone batteries and stuff. Okay.
So lead acid has a much higher recycling rate because they're the typical ones you have in your car. They're big. You can't just... You could throw in a dumpster of your neighbor's that's remodeling, but usually you recycle it or wherever you get your new battery, they take it. But unfortunately, batteries are loaded with toxic chemicals. These are chemicals that you wouldn't want on your skin or in your ground. So you got things like cadmium, lead, zinc, manganese, nickel, silver, mercury, lithium, and tons of acid types. And these all contribute to air pollution, water pollution, soil pollution. And
I figure the water pollution must be real bad with this.
Yeah, because you've seen what happens with batteries whenever they rust and they explode or they kind of crack open and like all that stuff
I hate
comes
when
out.
I leave them in something too long
and they get white. That white stuff builds up. So batteries are not great for the environment, unfortunately. I think when recycled properly, they are. And this is a big problem for companies like Apple and Samsung because they have these batteries inside of their phones that if they don't get recycled properly, they end up in a landfill and they cause all these problems. And that's why there's all these. And check out our e-recycling. E-cycling, I think we called it.
You're not hipster enough.
It's a big issue.
It is.
Recycling, especially with the sheer number of smartphones that are produced each and every year. So, not good for the environment.
Man, look at you caring about the carbon footprint again. No,
another
that was
fun
good.
fact.
Yeah.
The smallest commercial battery, and this was a few years ago, so there might be one smaller. It's a 2 millimeter shaped battery that's like a needle.
Is that like 1.5 inches?
It's about 6 feet.
Okay.
Yeah, so 2 millimeters, and it's typically used to power extremely small medical devices. Think of like maybe a hearing aid or like maybe a pacemaker something that goes in your heart. Yeah, something like that. So.
Oh, wow, that's very fun fact.
Yeah.
2 millimeters.
2 millimeters. That's pretty small.
That's very small, I think. Or not. Okay, a few types of batteries. Some of the biggies. How about that? So there's a ton of different types of batteries. Like, I didn't realize that because I'm ignorant. But there are all sorts. And I'm not talking like A, AA, AAA, whatever. But how about lead acid? So these are the most common types. And this is just a little bit of background information about these types so you don't sound as dumb as I do. They're the most common type of battery used in automobiles and to store solar energy because they can provide high current and their cost is pretty small. So that's pretty nice. They store only about 25 watt hours per kilogram, and each cell consists of lead electrodes and a sulfuric acid solution. And one lead electrode is coated with lead oxide. Connecting 6 of these cells in series gives you a 12-volt battery. So just some of the common stuff we know. Then the lithium ion, which you've talked about already. It's used in things like computers and consumer electronics, things like that. And work is underway to adapt these for other applications because they have a greater power density. They store about 150 watt hours per kilogram versus the 25 that the lead acid had. The electrodes are lithium cobalt oxide, LiCoO2, and graphite with a solid lithium electrolyte. How stuff works. I love stealing stuff from them, so thanks for the work. Ooh. They have a whole bunch of extra information on these batteries.
Okay.
And then the last one I wanted to mention is the nickel metal hydride. The metal of the nickel metal hydride battery is an intermetallic AB5.
I was thinking it was either an AB5 or an AB4.
Yeah, AB, Antonio Brown. Yeah. Good riddance.
Good riddance.
Pittsburgh don't miss you, Nat. You're not welcome downtown. Anyways, so the AB5, where A is a rare earth mixture of lanthanum,
Yeah.
cerium, and neodymium. And then parasidium. And the B is nickel, cobalt, manganese, and aluminum. And they store about 100 watt hours per kilogram and are much more thermally stable than the lithium ion. So a lot of this has been used for the work for hybrid vehicles, and then things that have to worry about temperature control are a lot more.
Because batteries can get hot.
It turns out they can, which is surprising.
That
to
chemical
me.
reaction inside of it.
Yeah, chemical reaction. That's the noise it makes,
It
too.
does.
You can't hear
They're
it.
really noisy
but,
sometimes.
Yeah. So that's all. Do you have anything else about batteries? How they're made, their history, anything else?
Did you ever take, what is it? Is it a 9-volt that has a 2 on top?
Oh, yeah.
Did you ever take the 9-volt
Stick it
and
to your
stick it to your tongue?
I like that. I do that sometimes. I kind of like the sting.
Yeah.
How about you?
I convinced
The
my daughter.
taste, too.
Yeah.
Tastes weird.
I convinced my daughter to do that, I don't know, maybe 2 years ago.
good parenting.
And my wife yelled at me.
JP approves of your parenting skills, by the way. He wrote in with your Thanos
Nice.
Avengers rant and said you're doing a good job. So
gotta
I'm sure
tell
he
me that-
approves of this as well.
You got to tell me that more often.
I don't need your ego to be any bigger. Exactly. All right. Hopefully you all learned something about how batteries work, how batteries are made,
Recycle your batteries, people.
and to recycle
Save
your
the earth.
batteries. Well, until next time.
See it.